Assalamualaikum to our lecturer, Dr. Muhammad bin Abu Talib. Our group is Group 5, Section 1, Video Talib 2. Theme or title is Problematic Soil and Crop Improvement. Our group mate is AHMAD bin SAPUAN, ISMAIL bin AMRAN, Muhammad HANAFI bin SOLIMAN, Muhammad FIKHRI bin ZUHAIDI, and Muhammad Hamizan bin ISMAIL. My name is Muhammad FIKHRI bin ZUHAIDI, CF 200-141. Today I'm going to discuss about introduction of problematic soil and crop improvement. Problematic soil are soil that have been features that make it uneconomical to cultivate crops without implementing suitable reclamation methods. Meanwhile, crop improvement is known as the altering of site, foundation, soil, or project earth structures to offer improvement performance under design and operational loading conditions. One of the problematic soil that has been chosen by our group is peat soil. Peat soil is a type of soil that made from decomposed organic materials that form for over 1,000 years. This figure 1 shows the peat soil. Next is the problematic of peat soil. The problematic is deep peat management. As you can see, in figure 2, deep peat management. In Malaysia, there are 2.4 million hectares of peat and with 1.5 million hectares in Sarawak alone, which is in Malaysia we have many million of hectares which contain peat soil. Deep peat has physical and chemical properties that cause issues due to its low physiography and water retention ability of 20 to 30 times of its own weight. Peat stores an excessive amount of water in its natural condition. It also produces an unbalanced nutritional environment for plant growth, which is this peat soil contain many of the problem issues that if we are not getting the soil with true condition, which is the peat soil will be low physiography and low water retention ability that can cause excessive amount of water in its natural condition. The figure 3 shows deep peat soil in Sarawak, Malaysia without wood. The figure 4, peat soil in Sarawak, Malaysia with decomposing wood. Meanwhile, in figure 5 is peat soil in Sarawak, Malaysia with undecomposed wood, which is Naman, Telok, and Benong. Line of the soil. Next is the application and recommendation for treatment of peat soil, which is by protecting peat lands. We can avoid deep drainage, which will be a solution for peat soil problematic. Other than that, maintain the water table over summer. By keeping the water table high in drier periods, it's important for pasture growth and maintaining soil quality for both peat and mineral soil, which is 2-in-1. We can save the peat and mineral soil. This can be achieved by putting weirs and or stop gates in your drains, which is we can save the peat soil. We can save by protecting peat land by putting the weirs and or by stop the gates in your drains, which is put something to stop the gates in the drain to protecting the peat lands to save peat soil. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is ISMAIL bin AMRAN, numeric CF 200-162. So today I'm going to present about problematic peat soil and ground improvement. As we know, peat soil has typical characteristics, which is high natural moisture content, high compressibility and water holding capacity, low specific gravity, and many more. As we know, peat soil is the representative material of soft soil and classified as a highly organic. Peat deform greatly under applied loading on account of its exceptionally high water content and organic nature. Other than that, it is also subject to very large primary and long-term settlement under an even moderate increase in load. Peat also has remarkably high strength compared with mineral soils at similar water content. And last but not least is peat is subjected to problem of instability such as local sinking and development of slip failure. Next, we move on to the problem, which is the problems come when the pit soil is untreated. It means pit soil has a low shear strength, high compressibility, and long-term consolidation, which is resulting in massive deformation. The shear displacement curve of untreated and treated pit soil with varying amounts of additive is shown. Because of the angular properties of the sand particles, a relatively high value of friction angle can be expected at the control sample. Previously discovered that fibrous pit is arranged under normal pressure. Furthermore, the friction angle for unprocessed granular pit and fibrous pit is in the range in some circumstances. The high friction angle does not imply to the pit strength. And last but not least is it contradicts the presence of fiber content in a pit soil.
Next, the application. Treated pit soil. We use lime and cement because the addition of lime has influence in reducing the optimal water content and increasing the maximum dry unit width of dry density of the pit soil. For cement, we use cement because of the stabilization is the most common stabilization method adopted for soil treatment. Other than that, the finding of the experiment revealed that the addition of lime and cement improve the strength properties of the soil. Next, the high shear strength of pit does not correspond to the high friction angle. This is due to the fact that fibers are not always solid and might be filled with water or gas. Stabilizers such as lime and cement are determined by their chemical reactivity with soil element in the presence of water, and the percentage of stabilizer agent used. Lime Ca+2 is added to improve the connection between soil particles. The soil particles get closer to each other, changing the texture of the soil. And lastly, lime content, short-term response, and soil mineralogy are all elements that influence lime-treated soil. That's all from me. Thank you.
Hi, Assalamualaikum. My name is HANAFI SOLIMAN. So I will present about the one of problematic pit soil and ground improvement of pit soil. So I has found one case study about problematic of pit soil. So as we know, construction of infrastructure on pit soil land is a very challenging task because of its low shear strength, high compressibility, and high water content. This paper summarizes various solutions that could be used for pit soil infrastructure construction. So as we know, if we build a infrastructure on pit soil, it's very difficult because pit soil have a high water content. So this is example, the large amount of organic substance and water content in pit soil. So I will explain the solution or application for this problem. Okay. The most common problems associated with infrastructure construction, pit settlement, low bearing capacity of pit, poor stability of pit during excavation, and a high groundwater table. Several solutions were proposed to address these issues. To control settlement, the arching effect of aggregate could be used to replace suspended slab. The pile foundation can support aggregate arranged in the shape of arch. The aggregate arch support the loads of traffic and road embankment, which are transferred to the hard layer beneath the ground via the piles. So this is an example aggregate arch with pile foundation. So application for next application is dewatering. Dewatering, the construction site on pit is known to improve the engineering properties of the pit, ensuring slope stability during excavation. So this is example, dewatering scheme using extraction well and recharge pond. Okay. However, excessive water extraction causes significant ground settlement, and it, in most cases, affect a large region. This could have an impact on existing structure near the construction site. And the next application is replace pit soil. Okay. Pit could be removed to expose a firm layer with adequate bearing capacity and replaced with appropriate materials with the desired engineering properties, such as a road embankment. This method is economical for depth of up to 4 meters. For this suspended slabs are usually adopted with a minimum amount of earth filling. The void underneath the suspended slab is recommended to be filled and compacted in order to prevent accumulation of the hazard gases. So that's all about my case study about case study on construction of infrastructure on pit soil. So thank you.
Assalamualaikum. My name is Muhammad Hamizan bin Ismail. My matric number is CF 200-125. To my lecturer, Dr. Muhammad Khaidi bin Abu Talib. Today my title is Problematic Pit Soil and Ground Improvement. The problem for my topic is due to the fact that the water content of wild landfills such as pit can naturally vary over a wide range of values, from dry to fluid in water. Second, due to the fact that water represents a significant energizing moisture content is the single most important property that governs the ignition and spread of smoldering wildfires. Third, due to the important role that moisture plays, natural or anthropogenically induced droughts are the most common cause of large fires that continue to smolder for an extended period of time. Fourth, higher mineral loads mean that soil can only ignite at lower moistures. The solution for the problem is number one is piling is one method that can be used to transmit the weight of a building's load to the ground below. Second, piling ought to be constructed using long-lasting materials. For instance, RC piling makes use of a minimum of grade 45 concrete to ensure that it is robust and does not easily crack or break when it is planted in the ground. Third, a significant portion of the Malaysian construction sector makes use of reinforced concrete piles, which are referred to as RC piles in abbreviated form. Fourth, this is due to the fact that the majority of Malaysia has a very simple soil structure, which makes it possible to utilize this kind of piling. That's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. My name is FAUZI bin Muhammad SAPUAN, and my matric number is CF 200-148. For problematic of pit soil, okay, the first one, pit soil has a very small bearing capacity, and the soil cannot support the weight of small structure. Okay, when the soil is subjected to the moderate load, this will cause long-term consolidation settlement occurs most of the time. Pit soil has a large water content, word ratio, high permeability, and low shear strength, so it can cause the failure of the foundation and the buildings will collapse. 30 centimeters below from the surface of the pit soil has a high percentage of the moisture content, which is result to the shrinkage limit and have lower shear strength. Okay, at the below picture, we can see the settlement of the buildings. Okay, the application of problematic pit soil. Okay. By using the groundwater barrier, it can control the groundwater seepage and slope failure. Okay. The flow of water may increase and will cause slope sliding during the excavations. And the last one, dewatering method can extract wells and recharging ponds in order to lower the water table level, which is to remove and pump the water with high air handling from the ground. Okay, we can see the picture below. This is the method of dewatering. As we can see from the picture below, this is the process of pump the water from the ground.